In this module, we will further talk about the probability. Since we already talked about the random events and events, then comes the probability. The probability is defined as objective probability and subjective probability. Whereas the objective probability has two different ways to describe it are classical definition of the probability and a relative frequency definition of probability. In the early 1950s, L.J. Savage gave a much importance and very much emphasis on this personalistic or subjective concept of probability. This subjective concept talks about that the probability utilizes intuition. It also utilizes experience and collective wisdom to assign the degree of belief to any event for its occurrence. As an example, the probability that a cure for cancer will be discovered within the next 10 years. Or a medical doctor tells a patient with a newly diagnosed cancer that the probability of successfully treating the cancer is 90%. In this second example, the doctor is assigning a very subjective probability of 0.90 to the event that the cancer can be successfully treated. Such a probability cannot be determined by objective definition of the probability. The first objective definition of the probability is the classical definition of the probability, which is a priority definition. This concept dates back to the 17th century with the work of two mathematicians, Pascal and Fermat. Much of this theory was developed out of the attempts to solve the problems used in the gambling, where they called it the game of chance, such as those involving the rolling of a dice. It's defined as if an event can occur in n mutually exclusive and equally likely ways, and if m of these possesses a trait e, the probability for the occurrence of e is equal to m by n. If we read P E as the probability of E, we may express this definition as PE is equals to M by N, where M is the number of times the favorable outcome occurs, that is, E occurs, and N is the all possible outcomes of this experiment. For an experiment consisting of n outcomes, the classical definition of probability assigns probability 1 by n to each outcome or sample event. For an event A consisting of k outcomes, the probability of event A is given as k by n. Let's look at this example for the classical probability, where this following table gives the information concerning 50 organ transplants in the state of Nebraska during a recent year. Each patient represented below had only one transplant. So there were 10 such patients who had the heart transplant in less than 1 year. And moreover, there are 5 patients who had the heart transplant 1 year or more. So if we want to find out the probability of patient receiving the heart transplant, out of 50, there are 15 patients who actually received the heart transplant. So this probability turned out to be 0.30, which is ratio of 15 by 50. The relative frequency definition of the probability is the posterior probability. The relative frequency approach to the probability depends upon the repeatability of some process and the ability to count the number of repetitions, as well as the number of times some event of interest occurs. It's defined as that if some process is repeated a large number of times, let's say this is n, and if some resulting event with a characteristic E occurs m times out of these n times, the relative frequency of occurrence of E is m by n, will be approximately equal to the probability of the event E. If we want to express this definition in compact form, we write it that probability of an event E is equals to m by n. We must keep in mind, however, that strictly speaking, m by n is only an estimate of the probability of E. Let's take an example for the relative frequency probability. A study by Lahore Traffic Police found that when 750 drivers were randomly stopped, 471 were found to be wearing seat belts. The relative frequency probability the driver wears a seatbelt in Lahore while driving is 471 divided by 750, which is 0.63. So there are 63% chances that a person who is driving in Lahore would be wearing the seat belts. Classical definition of the probability cannot be applied if the assumption of equally likely does not holds. The definition becomes vague when the number of possible outcomes become infinite. Thank you.